Hello, students. Today we're going to master a super important topic for your exams, arithmetic progressions, or APs. Now, it might sound a little complex, but trust me, by the end of this, you'll see it's actually one of the most logical and straightforward chapters you'll come across.
So, to get started, let's think about where we even see this kind of math in real life. Turns out, patterns are absolutely everywhere once you start looking for them.
For instance, think about this. Let's say someone gets a starting salary of 8,000 rupees, with a guaranteed raise of 500 rupees every single year. Or take a look at a ladder where the rungs get shorter by exactly 2 centimeters each time you go up. What do they have in common? Well, they both follow a very fixed, very predictable pattern.
And that predictable pattern, that's the whole idea behind an arithmetic progression. Okay, so what exactly is an AP? Let's dive into the core concepts. An arithmetic progression, or AP, is really just a list of numbers where you get to the next number by always adding the exact same amount to the one before it. That constant step, that fixed number, is the key to everything. Every AP has to start somewhere, right? We call this the first term, and we use the letter A to represent it. Just think of A as the launching pad for our whole sequence. And what about that fixed number we keep adding? Well, that has a special name too, the common difference, and we call it D. And here's a cool thing. D can be positive if the numbers are getting bigger, negative if they're getting smaller, or even 0. It's the secret ingredient that defines the entire pattern. Let's see this in action. Take the sequence 4, 10, 16, 22. How do you get from 4 to 10? You add 6. How do you get from 10 to 16? You add 6 again. That constant jump of plus 6, that's our D. Simple, right?
Okay, we've got the basics down. But what if I asked you to find a term way down the line? Like the 50th term? Or maybe the 100th?
I mean, can you imagine writing out all 20 numbers one by one? No way. That would take forever, and it would be so easy to make a small mistake. Luckily for us, math gives us an amazing shortcut. And here it is. This is the magic formula. Seriously, this is the most powerful tool in this entire chapter. With this simple formula, you can find any term you want, the 10th, the 50th, even the 1000th, without listing anything out. You know, the best way to really understand something is to just do it. So, let's solve a problem together, step by step. You've got this. All right, here's our first problem, taken right from your textbook examples. We need to find the 10th term of the AP 2, 7, 12, and so on. Let's break it down. Step 1 is always the same. Identify A and D. Before we can use our formula, we need our key ingredients. So what's our first term, A? Looking at the sequence, it's pretty clearly 2. And what's our common difference, D? Well, we just take the second term and subtract the first. So 7 minus 2 gives us 5. Okay, step 2. We substitute these values into our formula. We're looking for the 10th term, so our n is 10. We already know A is 2 and D is 5. So we just plug everything in. A10 equals 2 plus, in brackets, 10 minus 1 times 5. And finally, step 3, we just solve it. Now remember your order of operations. BODMAS is key here. First, we do what's in the brackets. 10 minus 1 is 9. Next up, multiplication. 9 times 5 is 45. And last, we add. 2 plus 45 gives us our final answer, 47. And there it is. The 10th term in this AP is 47. See? Not so hard when you follow the steps, is it? Great job working through that with me. All right, fantastic work. Before we wrap up, let's do a super quick recap of the most important things you need to remember for your exams. So, the key takeaways are, know what an AP is. It's just a sequence with a constant jump. Always identify A and D first. And of course, memorize that magic formula. It is your best friend for this chapter. And here is my #1 exam tip for you. Please be so careful with negative signs. To find D, you must always subtract the previous term from the next one. So, for example, if the sequence is going down, like 100, then 70, then 40, you have to calculate 70 minus 100, which gives you a negative D of minus 30. Don't fall into the trap of doing 100 minus 70. It's a classic mistake, so keep an eye out for it. Keep practicing, and you'll do great.